Our guest this evening is a return. He's got a lot of topics to talk on. So this one sounded interesting to me. John Portune. I pronounced it right, didn't I?
Just Portune. We dropped the French E, which was originally
Oh,
pronounced.
we did. All right.
Yeah,
So it's just Portune.
that's all.
Is going to talk about a 10-meter Moxon antenna, which is one that I'm not all that familiar with, but it sounds very interesting. So I will go ahead and turn the meeting over to John. I am going to actually eat my dinner, so I'm going to turn my video off so we don't have to watch me eat Chinese food. So over to you, John.
All righty. Click the share screen here. Bring up the PowerPoint. And go to the slideshow from the beginning. Okay, turn off all my little icons over on the right so I don't cover up the screen. And we are ready. Okay. And I'm going to move the toolbar up top there as well. All right, tonight we're going to talk about an antenna, which is pretty well documented on the internet, so I don't have to say a great deal about it. But it was, this particular lecture was created or prompted by QST, which, as I'm sure you know, I write a good deal for, now up to 29 articles, I think. They wanted an article on building a 10-meter Moxon, because I think they thought it would be good for their newbies. The new editor of QST, after Steve Ford retired, Becky Schoenfeld, is pretty devoted to the newbies in ham radio. She was the editor of the new On the Air magazine, and they asked me one day in an email, "Hey, Johnny, you got anything on a 10-meter Moxon?" And I said, "Yeah, we can do something on that." And that's what this is about. Some of you won't find this a particularly sophisticated talk because it's pretty basic, but yet it's an antenna that even if you've been around a while, you might not be that familiar with. And it is a good design. One of the reasons, of course, that they were interested in it is because, as we seemingly all know, the sunspot cycle 25, which is the one on the right, is greatly outstripping its predictions by the ISES people who keep track of these things and did this graph. And as you'll see at this particular time, the sunspot numbers were way ahead of the purple line. Now, I don't know whether it's going to be a great cycle or not, but we're all hoping it will be. The Moxon antenna, which is a name you've probably heard, but you may not be that familiar with it because it tends to be a kind of not exactly a junior antenna, but a less than maximum size multi-element beam, but still a good little performer, was sort of developed by Les Moxon, where it bears his name, G6XN. He wrote the article for the RSGB Journal back in 1993 on NHF ham antenna for all locations. Now, a couple of radio luminaries, particularly Jerry Sevick, who maybe some of you will recognize the name if you're into the technical gurus of ham radio, W2FMI, was a big fan of the Moxon because he felt it was constructionally and convenience-wise a very good little antenna. He was, of course, now a silent key as of 2009. And the Moxon has made quite a bit of notoriety in ham radio. And here's an article on it by Larry Seebeck, who's also another radio luminary who wrote a lot of good stuff on ham radio. And up at the top there, I show you a QR code. That's for a little calculator. If you've got your cell phone camera handy, take a picture of the QR code, or ask Paul, who's recording this session, and you'll get that QR code. And get yourself a copy of Moxon Calculator. It's the name of the program. And it will do all the calculations you want to calculate the Moxon. It was based on the original basic program that Civic wrote some time ago. But here's an article back in 2015 where the Moxon was emphasized for field day use, because it is a good, very light antenna, because it's basically a wire antenna, basically a wire beam. And that's not real common, because most beam antennas, most Yagis, are built out of tubing and are much heavier. This is a wire Yagi. In fact, here is the Moxon in its basic configuration. It is, as I said, a 2-element, close-space wire Yagi with folded ends. Now, we all know that the Yagi can be optimized by playing with the lengths and spacings of the elements to give you either more gain or better front to back or better side lobes. And the particular calculator that I showed you a minute ago, and I'll show it later here, does all the calculations to make the Moxon turn out to be this way. Gives you the exact dimensions for it. But basically, if you look at the Moxon, it is a driven element out there at the top of the screen with the ends folded into 2 insulators. And then it's also a reflector. And the reflector is placed at the optimum spacing for forward gain, principally, not so much front to back, but for forward gain. But the nice thing about it is it's a wire antenna. There's no aluminum tubing involved in this antenna, maybe except for the masts. The antenna is held up by fiberglass spreaders. Now, you might, one little point of interest, which some of you probably well know, but if you're going to take a dipole, like the driven element, and add 1 element to it in Yagi in fashion or parasitic action, it's better to add the reflector as the first element, because you get more gain and better directivity shaping with a reflector than you do with 1 director. So the optimum 2-element Yagi is always a driven element and a reflector. There's the actual radiation patterns of this particular little antenna. And it's pretty typical of most Moxons, whether you build it for 10 meters, as I'm showing you principally here, or you build it for other bands, which I'll also say something about. And this particular antenna that we built, my good friend of mine, W6NBC, was actually the one that physically built the antenna mechanically. I bought the parts and he built it, is up at half a wavelength when these particular radiation patterns were shown, the elevation and azimuth. And I have a general rule of thumb. You might want to put this, make a note of this, particularly if you're a newbie to ham radio at all. You might want to note this, that any antenna that isn't or any horizontal antenna that isn't at least a half a wavelength high is omnidirectional and a cloud burner. It's an NVIS antenna, or a near vertical incident skywave antenna. But once you get above half a wavelength of the horizontal antenna, then you begin developing gain. This is why people who put up 40-meter dipoles in the backyard at 25 feet might worry about which way is it aiming. Don't worry about it. A 40-meter inverted V with the apex at 25 feet is omnidirectional, and all the energy goes straight up. But so that's why I put this one at 15 feet, which is not a very great height for 10 meters, but it's proportional. So if you built a 20-meter one of these, you'd have to put it up at proportionally greater height, like 30 feet. Now, the Moxon calculator that I showed you, this SWR curve is what turned out. All my buddy Jim did, was use the Moxon calculator, set the wires exactly at the dimensions that the Moxon calculators did, and then ran an SWR curve. This is one I ran later on in EasyNet, But as you can see, even right out of the box, right out of the calculator, it got the SWR across a good portion of the band, across all of 10 meters. It got it down to under 2 to 1. You can get it lower than that with a little tweaking, but you can see the calculator does work. And here is the calculator. Here it is again, in case you want to capture the place to get it, tippit.net, CGI bin, moxgen.pl. The name of the program is Moxgen, Moxgen. And that's the QR code up there that'll take you straight to this website. All you got to do to run the calculator is a piece of cake. Just put in the frequency you want to build the Moxon for, or you want to build the Moxon loop in case you're building a 2-band or 3-band Moxon. Just put in the frequency you want for the particular loop. In this case, I put in 28 megahertz, and the wire size you're going to use, 14 American wire gauge. Push the calculator, and it'll give you a nice little table showing exactly how long all the elements are. Very simple little calculator. If you want the algorithm for that, it's down below. It was generated by Larry Siebeck, and that's his URL down there in case you want to go to the website about the calculator. Okay, that's enough. Now, when QST asked me if we could do a Moxon, I started off and made a design, sent it to them, and they sent it back. I don't like this. Can you make it with fishing poles or bamboo spreaders? Because I was using PVC, Ham's favorite building material, and they didn't like it, so they sent it back. So we redid it. We went through 8 revs of this Moxon until we made QST happy. This was one of the interim items that W6OEK, my buddy Jim Bailey, created. But one of the most difficult things with building a Moxon or this kind of an antenna is the central hub in which you insert the fiberglass arms or the fishing poles or the bamboo spreaders to take the arms out to the length or the size of the Moxon. And this is just a couple of pieces of EMT tubing squashed in the middle and clamped onto a mast. And this was a pretty good central mount. This was one of 8 revs, though, until we got the article right, and they finally accepted it, and it's the one I'm showing you here tonight. The basic design of the Moxon follows very close to this antenna, which some of you may know about, or even have one of these. The now infamous hex beam or spider beam, which is made by putting bendable fiberglass spreaders into a central hub, attaching that to the mast, and then putting wire around it to form your Yagis. This is the multi-element spider beam, which is basically sold by Max Gain Systems, who, by the way, sell all the fiberglass and everything to build these, as well as it's a good place also to buy the fiberglass tubing if you want to build a Moxon as well, because the Moxon is just 4 of these 6 spreaders. That's all. Same basic design. Wire around fiberglass spreaders pulled up under tension. Although in the case of the Moxon, I decided, we don't need to pull it up. Let's let it droop down. That's much easier. Why bother with that top set of guy cables and an extension? Just let the fiberglass wires droop down instead of up. It's easier. And that was the design we went with. All right, here's the basic mechanical structure of this antenna. It's a piece of cake build, believe me. Get yourself a couple of metal tubes in the middle. I'll talk about them in a minute. And you bolt them with a couple of C-clamps to the hub. And then you insert into them 2 sections each for each of the spreaders, pultruded fiberglass tubing, which you can obtain from DX Engineering or Max Gain Systems quite readily in all sorts of nesting sizes, bigger and smaller. This is a piece of 1/2 inch and a piece of 3/4 inch fiberglass tubing from Max Gain Systems in this particular, 4 feet long. By the way, if you order this stuff from them, order it 4 foot lengths. Don't buy the 6-foot lengths. You can get it in 6 foot. You can even get it in up to 12-foot lengths if you want, but then you'll pay exorbitant shipping freight charges. But in 4-foot lengths, it can be sent by UPS, and the shipping charges are modest. So that's why we stuck to 4-foot lengths of this tubing to build this Moxon, or also to build a spider beam if you want to do that too, which you can use the same design for, by the way. Works just as well to build spider beams or hex beams. So as you can see, there are 8 fiberglass spreaders at the proper angle as determined by that calculator, actually determined by the dimensions of the wire loop around the outside. And the 1/2 inch ones are slipped into the inside of the 3/4 inches and held under tension with the little square clamps that you see there. There's typical hose clamps to use to tighten up or to tension the spreader arms. At the ends are the 2 insulators. These are just some short lengths of 1/2 inch PVC pipe with holes drilled in them for some screws to which you attach your wire. It's a piece of cake, dead simple. And those, by the way, are the exact dimensions that came out of the calculator, showing that the antenna is 143.5 inches long, 55 5/8 inches wide, and that the two individual end pieces to the insulators, 21.5 and 30.25. Easy to adjust those if you want to, and easy to get everything matched up properly. But right out of the calculator, right out of the box, it worked. So we didn't even have to bother. And as I said, you can buy all of this stuff from DX Engineering or Max Gain Systems, ordered in 4-foot lengths. That's what you want to order it in. Here's the central hub. Very simple design also. It's 2 pieces of 7/8 inch thin wall aluminum antenna tubing, which you can also buy from DX Engineering or Max Gain if you want to. But you can also use 3/4 inch thin wall EMT conduit, which you buy at your local hardware store. Or if you've got a metals dealer in town, I do, and my town is a fairly small town. I'm sure around Gary, Indiana, there's going to be a metals dealer somewhere. Just go down there and buy some 3/4 inch Schedule 40 aluminum pipe. By the way, aluminum pipe has a different set of dimensions than fractional or like 1/2 inch, 3/4 inch aluminum tubing. Aluminum tubing is measured in outside diameter. Schedule 40 pipe is measured in inside diameter. And by the way, Schedule 40 aluminum pipe is exactly the same size as Schedule 40 PVC pipe. So it fits into PVC fittings. That's why I like it. I can build antennas using PVC pipe, Ham's favorite building material, and Schedule 40 pipe, and make antennas with it. Great thing. Couple of common mast clamps, which you can buy easily. Buy them for the size of the mast you want to use. Just 1/4-20 U-bolt mast clamps. And they're at an angle here. That's why there's a slight offset in where you drill the holes. And by the way, don't worry about the angle. You don't have to determine the angle yourself. When you put the wire on the spreaders, leaving one of these central mast clamps loose, the angle will be automatically determined for you. Then you tighten up the one clamp you left loose. You don't have to set the angle. Now I show you this one for fun. What is this? Besides looking like a disaster. Well, I showed this same presentation to the Pentagon Amateur Radio Club, which I've spoken to 2 or 3 times. And one of these people said, yeah, I've got a hex beam. Let me show you a picture of it. And he dug through and shared this picture. This is his hex beam. I said, oh boy, what a disaster. And by the way, I thought it was a black and white photo. It's not. Notice the blue fringe on the house next door? It's a colored photo, but it was snow. Everything was black and white. I said, boy, that was a disaster. I bet you had to do a lot of work on that one. He said, nope. I just went outside. Once it thawed, pushed it all back in place, went right back in place. Nothing broken, nothing lost. And yet it came down in the ice storm just like this. So if you don't think this is a tough design, it is. It's a good design. It might come down with ice loading, but you can put it right back up again. All right, let's build one. Here are the insulators. as I said, just common 1/2-inch PVC pipe cut to a specific length based on the calculator, with a couple of holes drilled in it to run the wire through and to fold it back and to secure the wire. And the fold back is not counted in the length of the wire, because when you fold wire back, the antenna only sees the length of the transmitter only sees the length of the wire out to the fold back. And there's the feed point. And as you can see, it's an arbitrary size here. I had put 1-inch spacing with 1 inches in between. I just arbitrarily used those dimensions. You could make this center point or feed point insulator almost anything you want. In fact, here are the actual dimensions if you want to look at these afterwards from the recording that Paul is making. And as you can see, it's just Schedule 40 PVC pipe. If you want to, you can even cut the PVC pipe lengthwise in half so that you reduce the weight a little. But the antenna is light. I can pick up this whole antenna in one hand easily. Here's the feed point insulator. As you can see, a couple of I think they're 832 stainless steel screws come through, a couple of nuts and some crimp-on ring terminals, and then the wires folded back. These are ones that my buddy Jim used some little crimp sleeves to secure the wire in the insulators. But you can just wrap the wire around if you want, works just as well. And here are the hub tubes. As I said, you can use 7/8-inch thin wall antenna tubing from Max Gain system if you want. Or you can just go down to your local hardware store and buy some 3/4-inch EMT conduit, aluminum or steel. I recommend the aluminum, of course. Or you can go down to your local metals dealer and buy some 3/4-inch. Maybe you'll find it in the scrap bin. For all I find most of my metal stuff down at my local metals dealer in the scrap bin. From just some 3/4-inch Schedule 40 aluminum pipe, not 3/4-inch fractional aluminum tubing, but they sell that too. Metals dealers sell both aluminum tubing and Schedule 40 pipe. Remember, Schedule 40 pipe fits PVC fittings, so that's very handy for building antennas. Okay, all right, these are the 1/2-inch fiberglass spreader arms, 4-foot spreader arms, the end of them from Max Gain or DX Engineering. You hold the wire passes through the ends of them in slots, not holes. Don't try to put them through holes. That's too awkward. Just get out a Dremel tool or a little cutoff disc and cut some little 1/8-inch wide slots in the end of the 1/2-inch tubes. The tension on the wire will hold them in very, very well. And so there's no problem there. In fact, we're going to hold them in even more securely here in a moment. What you want to do when you build one of these Moxon is to build it complete, already made. Build it on your workbench, cut the wire lengths to the calculator and build it complete. Crimp everything, wrap everything around the insulators, attach the feed point, the feed cable, as you can see here, and then take that out and put it on the spreader arms. The size that you made this will set the correct dimensions and the angle for your spreader arms. Here's the one that my friend buddy, W6OEK Jim Bailey, built out in his backyard. Simply took a little drill press vise, put a little piece of short stub of tubing in it to hold it up, and built the Moxon, a little 10-meter Moxon, right on that at 4 feet height. This is the easy way to build it. You can also, if you want to, just lay the pipe down horizontally on the table and build the Moxon in a vertical position. Either way is fine. If you build it this way, you might want to just leave that little stub there and clamp it to the mast and not bother with building it on the final mast. Or you can build it on the final mast by laying the mast on the table and building the Moxon vertically. Either way works just fine because it's a small antenna, easy to handle. Even bigger ones are, even lower frequency ones are. Here's a typical hose clamp that you can buy. Those are readily available on Amazon. Just search for antenna hose clamp or mass clamps, and you'll come up with one of these. And they're reasonably priced, $6 or $7 or something like that. Now, when you go out there and you put your Moxon on and you put the spreader arms in, and you've put them in roughly in place and assembled the hub tubes, and you got the spreader arms hanging out there, go and put the wire through the ends of the slots. But before you do, at the correct position as determined by the calculator, bend this little 1-inch hairpin loop. What's the purpose of it? It secures the dimensions of the Moxon very firmly. When you then tension it, the wire won't squirrel its way around and come to other sizes if you've got that little hairpin loop in the end of the fiberglass spreaders. Now, my buddy Jim called me on the phone or sent me an email. He said, I need a helper. I can't tension this antenna. I said, why not? He says, I need somebody to hold the fiberglass tubes while I tighten the screw. So that's the hose clamp he's tightening there, which holds it on. I said, Jim, think for a minute. It's very simple. Just grab the smaller spreader with your left hand, push on the hose clamp with your right until you get the right amount of tension, and then use a nut driver to tighten the hose clamp with your right hand. And he came back and said, yeah, my bad. You're right. You don't have to have two people to build this antenna. And there's the final product. That's what it looks like. Nice, neat little antenna. You can see all the elements I've been talking about, the two end insulators, the feed point insulator, the cable running back to the central mast held with zip ties. And by the way, a ballon. Highly recommend a couple of ferrite chokes on there to make the antenna work correctly. And you can see the wire running around from the end. Very light antenna. As I say, I can pick that whole antenna up in one hand very easily. And I'm an old 84-year-old geezer, so I don't have it. You can't claim age as a reason not to be able to lift one of these antennas. Interestingly here, and this is a little side story, a little war story. Notice the fact that this is Jim's picture with it up at 15 feet. Notice that he caught the moon in the picture. Not quite. I'm a big Photoshop fan. I love diddling with pictures in Photoshop. His moon was a quarter that size in his picture, but that wasn't difficult. I just took Photoshop, blew the moon up to 4 times the size, and put it back in the picture so it would make a great picture for this presentation. Then Jim tried it out, and here's the antenna. As you can see, I've kind of emphasized the wire a little bit so you can see it. He built this really clever little wooden stand to hold up a 15-foot high mast. It's just built out of 2 10-foot pieces of 2x4, cut into 3 pieces, one for the vertical and the little legs on the end, and the other for the horizontal, and 4 diamond-shaped pieces of 3/4-inch plywood. Nailed it all together with drywall nails, and it held the antenna up real spiffy. Had to put a block under the middle of it to hold it up a little. But a great little portable stand. I thought about writing an article on it, but decided maybe not. So finally, let's add some additional 4-foot spreader tubes. Use the same physical design and take this one down to 20 meters, 17 meters, 15 meters, 12 meters, and if you want to, 6 meters. And here are the general proportions. Just use that calculator. You can get these dimensions right with that calculator, real easy. But here's what it would look like. And you could actually build a 5-band if you wanted to. 1, 2, 3, 4, 6-band Moxon if you wanted to, by putting all 6 of these loops on the same set of spreaders. Now, of course, if you and get yourself down to 20 meters. Now, what I'm showing here, though, is each spreader now has to become 4 sections, not 2. The outer 2 are still the same, 1/2 inch and 3/4. Those are the ones used on the 10-meter one. But to get down to lower bands, you have to add additional 4-foot spreader tubes and more hose clamps. And but they're all 4-foot sections, all obtainable from DX Engineering or Max Gain, and they nest really neatly. And you'd have to add 1 inch, 1.25 inch tubes on the inside, but you could then put holes through them and build yourself a 6-span Moxon if you want it. And the proportions will still be the same. It will still be the correct two element max forward gain Yagi. And that's it, people. Here's my little doggy Lolly. She's a Shih Tzu. No, she does not have a German call sign. I just like to pretend that she does. And by the way, if you want to contact me or ask questions, that QR code up there will take you to my email, or you can reach me through my website, which is simple enough to remember, w6nbc.com, or my email, jportune, which is my initial and last name, at aol.com. And that's the simple and lovely little Moxon.
Very good. I have a question. Unless maybe I miss it. What is it fed with? Is it fed with coax, twin lead?
Yeah, coax.
Coax.
Yeah.
Okay.
No, there isn't any particular reason you couldn't open line feed it, but then you'd have an impedance transform. You'd have to use a 50 ohm to.
Right. So that, I guess that was my question. The feed point is 50 ohms.
Oh yeah, the Moxon calculator makes 50 ohm Moxons.
Okay, cool.
It could be, frankly though, just a little tip for you. Almost every antenna that you ever built might be 50 ohms at the middle, but if you move off center a little bit, it's some other impedance. Yeah. And generally speaking, all you need to do is move off center a little and you'll find 450 ohms. So if you wanted to open line feeder, you wouldn't feed it in the middle, you'd feed it off center.
Very good. Go ahead, Joe.
I was going to say, I have a quick question. You were talking about doing a multi-band where you're wrapping a bunch of different size loops on the same set of spreaders. If you do that, is there a tricky way to feed them all with the same coax?
Have you ever built a fan dipole?
Not personally, no.
But do you know what a fan dipole is?
I absolutely know what it is, but all of those come back to the same point.
You could do the same thing with this. You really could do it, or you probably could just run a little piece of open wire, 450 ohm open line between the feed points, and it would probably work with a little adjustment in length of the wire. It would work just as well.
Yeah. Yeah, so no, I was just curious if there was a
common feed
way to do that.
Common feed it with a little piece of open wire line, leaving the dimensions all the same, which would probably be better for the Yagi principle, or run all the feed points to the same place. It would all work. You just need a little adjustment in length, but that's not difficult to do.
I think that 10-meter one looks like a fun little club project for field day.
Well, it's a wonderful, and they wanted it in QST because of the upcoming sunspot cycle, where the newbies who have a 10-meter technician class licensees have a 10-meter segment. They can work FT8 or easily with this. That'd be a great little FT8 antenna.
Yeah. All right. Anybody else have any questions? Well, thank you very much, John. That was very interesting. And
all right, anytime. I'll be glad to come back. As you know, I've got oncoming topics that are coming up. I'm just about to finish off one I think will be a killer topic, and it's entitled Building the Optimum Mag Loop. Now, everybody says, oh, the mag loop. I built lots of those mag loops. Chances are most people who built mag loops have never built an optimized mag loop. This article is about an optimized mag loop. Let's optimize it in all ways you can optimize a mag loop. So at least 6 different ways that you have to adjust to get the mag loop optimized. It's not just size, it's not just diameter, it's not just material, it's all of those in combination. It also has to do with the neighbors. It also has to do with noise rejection. There's several ways you can optimize. That's my next topic, optimizing the mag loop.
Very good. All
I'll be
right.
glad to come back anytime and talk to you.
We appreciate that, John. Thank you very much.
Yes, indeed.
Have a good evening.